Our infrastructure is ageing. This applies both to our surface infrastructure, roads, buildings, bridges, as well as our subsurface infrastructure, our tunnels, pipes, embankments. Often we treat it as out of sight, out of mind. But the ground poses the biggest risk to any construction project, but also the biggest opportunity for our future cities. So we need to ensure we get the most benefit of our existing buried infrastructure. This means we need to use it in a sustainable and resilient way, taking into account not just the economic side, but also the social and environmental side. The ground, the subsurface, is a complex environment. It's affected by the material itself, so the soil, but it's also affected by environmental conditions. So climate change affects how our buried infrastructure behaves, or how our ground behaves, but also by the loading. So for example, additional traffic loading causes additional problems. So it's a real complex environment. So we need to develop new sensors, new methods, new materials to operate in this complex environment. And this is a real challenge. NBIF is unique. There's no facility like this in the world. We can do things at full scale or nearly full scale. We can test things in a controlled environment where we control not just the material but also the environment and the loading. Therefore, this really allows us to test new materials, new sensors, new methodologies. We can't do it anywhere else. NBIF is part of UCRIC. UCRIC is the UK Collaboratorium for Research on Infrastructure and Cities. NBIF has a visualization suite for collaborative working. We also have 2 knowledge transfer offices for industry to occupy during joint testing. NBIF has a sand-filled pit, which is 25 meters long, 10 meters wide and 5 meters deep. This can be used to build large-scale experiments, including static and dynamic loading. It can also be divided using legato blocks to change the scale of the experiment. It also includes a movable floor, which can be used to simulate ground movements, for example as a result of tunnel operations. The pit also has a strong wall, allowing horizontal loading operations. Surrounding the pit is a strong floor, which allows bespoke smaller scale experiments to be set up, as well as material testing using a structural frame. This is essential to fully characterize materials. Again, loading is achieved through a range of actuators, both static as well as dynamic. Material characterization can be conducted using a range of geotechnical testing equipment, including unsaturated and dynamic triaxial apparatus and a large shear box. Small-scale model tests can also be conducted in a mini geotechnical centrifuge. Geophysical sensors can be used in NBIF as well as in the field to fully understand the in-situ ground conditions and buried infrastructure. Novel sensing technologies, including optical fiber systems and quantum gravity sensors, supplement the suite of state-of-the-art sensors. Our state-of-the-art facility is open for business, not just in the UK but internationally. So come and talk to us and see what we can do for you to work collaborative in the future.